All right, good. Whatever day time you're watching this, I hope you're doing well. Where to begin? Today we are going to get into some chain application. So basically, we're going to take some concepts of simultaneous and sequential movement strategies and make it applicable to rehab, exercise, and human movement, in terms of activities of daily living, but mostly for rehab and exercise, because this is where you guys, the professionals, are going to be able to kind of play with these concepts to eventually help people. Okay, so let's first recall in 310, I taught you guys about two main types of motion. We have straight line motion and we have rotational motion. And a combination of those we call general movement, because generally we have a combination of both when we move. And when I got into movement strategies, I had mentioned how simultaneous motion has multiple joints that move at the same time, so that even though the shoulder has rotation, its rotation component, and the elbow has rotation component, when those two joints rotate at the same time, they can summate each other's translation. In other words, my shoulder is going forward, my elbow is going forward, My shoulder makes my hand go forward up to a certain extent. If I keep moving, then eventually it's going to go backwards. My shoulder initially is going to make my hand go forward. My elbow is going to make my hand go forward. So when I use them together, they are going to summate each other's translation and cancel out each other's rotation. When these joints cancel out each other's rotation, you get this effect. The cause of the cancellation of rotation affects a distal segment such as the hand translating forward. The fist, if you're throwing a jab, I'm left-handed, but a fist if you're throwing a jab, or your foot when you push off on the ground, the reason your foot, a distal segment, distal meaning further away, can push on the ground with force and accuracy is because of this cancellation effect with your knees and your hips. Your knees are trying to rotate you and make you go forward, and your hips are trying to rotate you, make you go backwards. Both of them are trying to get your butt up. So when they work together, they cancel out each other's rotation and summate each other's translation. But the point is that it's all in a strategy of influencing distal segments. Okay? So what we're going to talk about today is chains. Cha-ching chains. In your uh, supplemental packets, I have a section, and listen, this isn't meant for you to be a master at this. I'm not a master at this, and I've been doing this for a long time. This is just to introduce you to these concepts so that over time you guys can grow, develop, and add to these conceptual ideas, okay? Now, let me first start off by saying my background is in athletic training. I'm a certified athletic trainer, and came through this program back in the day. And sometimes the chains confuse me. And if for those of you that have never heard, sometimes we do exercises that are open chain, sometimes we do exercises that are closed chain, and that's a play off of the kinetic chain. So think about a quarterback throwing a football, and they may talk about the kinetic chain, the chain of events to transfer the forces to the ball. If technically we're talking about the movement, it would be the kinematic chain, where the chain of events in terms of motion to throw a ball. It's just an example, okay? So I remember kind of, some were kind of obvious, like doing push-ups would be closed chain, meaning that your distal segment isn't free to move around. When you're doing a push-up, your hands are closed and you move about the closed fixed hands. Versus if I was doing like a chest press, my hands would be, the distal segment would be open. They would be open to move about my fixed torso. Just an example. But sometimes things would kind of get confusing. Like, okay, I understand push-ups, that's kind of obvious. But what about like slide board push-ups? What that is if you were on, imagine your hands were on a slip and slide, where they could move, they can't move straight, but they can move perpendicular. So in other words, I can't simultaneously move my shoulder and elbow to make my hand free to go here, but I could just move my shoulder on a slip and slide, or I could just move my elbow on a slip and slide. So I was like, well, what's that? Is that closed? Is that open? It's definitely not as closed as when you're doing a traditional push-up with just friction preventing you from sliding around. And it seems that sliding around is kind of open. So what is it? Or if you look at variations of bench presses, so like push-up, closed, I got it, no problem. But what about barbell bench press? Well, that's open, okay, but dumbbell seems more open than the barbell. Like, at least with the barbell, I can't independently move my right arm from my left because that bar is kind of closing some of those roads. But with dumbbells, I'm free to move however I want. It's almost as if one is more open than the other, or if you want to look at it the other way, it seems like maybe one is more closed than the other. So there's something there. And so the concept of looking at distal segments in terms of their chains, in terms of their movement capabilities of their distal segments. Now remember, when we're talking about chains, we're not talking about joint motions. Joint motions is joint motions. Like, from my elbow's perspective, it doesn't matter if I'm doing a push-up or a chest press. Extension, flexion, extension, flexion. If I'm doing a push-up, flexion, extension, flexion, extension. When we're talking about movement of distal segments, it has nothing to do with joint motions. In addition, these concepts have nothing to do with which one is harder to do in terms of like effort, in terms of like muscular force. Not at all, because if you think about it, if I get on a chest press, I could take the weight stack and I could put it on 10 pounds. I could put it on no pounds. But if I'm doing a push-up, I'm bound by my body weight. When I do a push-up, there has to be a certain stack of force that I'm doing. I can't, unless I modify it through creativity, I don't have the precision of variability of the machines, okay? So I'm not saying chains are harder or difficult from a force or effort standpoint, but what I am saying is that the differences in these chains that I'm about to talk about, they are easier or harder to replicate the movements. The movement patterns can be easier or more difficult to replicate. Okay? And I'll get to why that's important. So what I realized is our bodies, we have sequenced motion, right? Motion done one after the other. We have simultaneous motion. Any joint motion that's done by itself in sequence. Guys, one joint motion is a sequence. It's a sequence of one. But there can't be simultaneous motion with just one joint motion. because that would be a dislocation. So think about that for a second. Any joint motion done by itself in turn is a sequence, but I cannot have simultaneous motion done by just one. Simultaneous motion has to be multiple. So if I just move my elbow, that's sequence motion. If I just move my shoulder, that's sequence motion. But when I have simultaneous motion to translate distal segments, or to have force and accuracy, like when I'm pushing off on the ground for a squat, that's force and accuracy. Okay? So in that regard, I have to have multiple joint motions moving at the same time. So this is what we realized, is that chains, whether the distal segment is free to move or not, can be looked at in two different ways, simultaneously and sequentially. This is where all this kind of comes together. So in other words, you can look at a push-up and say, okay, how can I potentially move my hand? I can move it simultaneously, elbows and shoulders, or I can move it sequentially, just elbow, just shoulder. When I'm doing a push-up and my hands are locked onto the ground, my hand isn't going to go through the ground because the ground closes that road. My thorax, my body is going to move about my closed hand, right? So when I'm doing a push-up, if you're looking up at me through the glass, like you're underneath this glass floor, that's kind of weird. Hands aren't going through the ground because the distal segment road is closed linearly. Because the ground has carpet or whatever the surface is made of, and because your hands have imperfections on it, like fingerprints that interlock with the imperfect surface of the ground, interlocking with the imperfect surface of your hand, those interlocks and the compression creates potential for friction. So when you're doing a push-up, not only are your hands closed to passing through the ground, but friction creates an environment where your hands are closed to slide past the ground. Friction closes the angular road. Friction closes the sequenced motion. And if you don't understand what I'm saying here, that's okay. Think of it like this. Think of it as if you had roller skates and you somehow put your hand in the roller skates. So you put your hands in the roller skates so the roller skates can roll. Think about it. If you did a push-up with roller skates on your hands, you would still have the same closed road going forward. You're not going to push through the ground with the roller skates. But all of a sudden, you're going to be a heck of a lot easier to move parallel with the ground. In other words, you're doing your push-up, you may slide. In fact, as you come up, odds are those roller skates are going to slide. They're going to roll, rolling friction. So there's this new road that's kind of opened. And that road that's open isn't coming right at you. It's perpendicular to the ground pushing back at you. And so again, if you think about it, if I'm doing this push-up, my shoulders can start to roll, or my elbows, if I'm going back, my elbows could roll out to the side or to the front. In other words, I didn't close every road. This is how slide boards work. If you don't know what a slide board is, you put on these special frictionless socks. There's friction, but there's not as much. And you can do these like shuffles from side to side, or you could do you do shoulder exercise or push-ups. You could wax on, wax off, like Mr. Miyagi taught Daniel-san. But that's the point, that you create an environment that is closed to movement of the distal segment in a straight line, you close simultaneous motion, but you are open to angular motion. You're open to sequenced motion. Okay? So there are two types of roads is what I'm trying to get to. There are two types of chain conversations. You have the straight line chain meant for simultaneous motion, and then you have the sequence chain, which is perpendicular to that, which is angular. So let's get to how we communicate these things. Well, the more traditional chain is the straight line. Push up closed, machine chest press open. So straight line movement of the distal segment through simultaneous motion is going to be our first chain communication. So examples of this: push up, closed to straight line movement of the distal segment. Traditional squat, closed to straight line movement of the distal segment. A pull up, if you're doing a pull up, your hands aren't going to move up and down like a lat pull down, but if you're doing a pull up, your hands are going to be closed to straight line motion. You're still going to have the same joint motions, but the distal segment isn't going to do this and this. It's going to stay put because that road is closed, and you're going to have motion about the fixed distal segment. So traditional straight line roads, open or closed. Okay. Now we get to the second option. Is it open or closed to angular? Is it open to closed to one joint motion moving by itself? Let me give you some examples of this. A machine chest press. Let me see if I could give a pull up. Wait, let me get my handy dandy. Do you remember from Phineas and Ferb, Doofenshmirtz? My handy dandy chest press calculator. Let's see. That was horrible. Perry the platypus. Let's see. Chest press machine. Doofenshmirtz Evil Incorporated. All right, so check this out. So the chest press. All right, chest press. So his thorax is going to be fixed, but his hands are going to be free to move. But again, let's think about this. His hands are free to move only forward and back. He can't independently make his hands go like this, and he can't independently make his hands move like this. Why? Because even though the linear road is open, the simultaneous road, if you need to move your hands, you have to move your elbows and your shoulders. But the sequenced road is closed. He can't just move his elbow. He can't just move his shoulder. So there is some element of this chest press exercise that is closed. The angular road is closed. Now, I know you're saying, well, all joint motions are angular. Yeah, we're not talking about it from joint motion perspective. We're not talking about elbow flexion, elbow extension. We're talking about the distal segment moving linearly or the distal segment moving angularly. It's a distal segment conversation. So this exercise would be open to straight line motion, but it would be closed to angular motion of the distal segment. Now again, you'd be like, so what? Well, let's compare the roads of, remember this, we're going to come back to it, of a dumbbell chest press. Now this is actually in your supplemental materials, okay? Dumbbell bench press. So check it out. Dumbbell bench press. So if someone said, what's the difference in chains between a chest press and a dumbbell bench press, it's almost like I think most people, their intuition is like, well, something's different. In other words, if you started out a new client in personal training, you probably wouldn't just start them out on dumbbell bench press because you know this. They're this arm's more dominant. It'd be hard to replicate the movement patterns because it's new. So what do? You start them off on a chest press machine so that the machine can guide their movement patterns and their muscles can get used to the movement patterns so that eventually when they progress to the dumbbell, they are much more likely to be able to replicate those patterns. So why is this exercise harder to replicate the movement? I didn't mean to get into your personal space. Because it's open. It's open to straight line motion, simultaneous, but it's also open to angular motion. In other words, my elbow can just move that dumbbell and my shoulder can just move that dumbbell. They don't have to move at the same time. They don't have to be in sync. You're tearing up my heart when I'm with you. We'd like for them to work together and we'd like for them to be on the same page, but they don't have to be because they are open to both linear and angular. Right and left, and right elbow, right shoulder, and left shoulder. They are all independent, so you can get some wild and crazy movement options. It's about accuracy of movement pattern replication when we're talking about chains. So think about it from this perspective. And again, a continuum. I love continuum, my favorite word. A barbell bench press, right? You say, well, what's the difference between a dumbbell bench press and a barbell? Well, the barbell would be less open to angular. They're still open to linear. But the barbell would be less open to angular. And when I say less, I'm saying that you can still have some angular, but it's less open to angular than the dumbbell. Why? Because at least my left and my right are synced up. I gotta move them together. I'd snap the bar in half. I can't independently do stuff with my left, and I can't independently do stuff with my right. The bar kind of creates a telephone link of communication between my right and my left. Now, I can still do some angular stuff that I can't do with the machine, but it is more closed in terms of angular movement prevention than the dumbbell. It's all a continuum. This is cool stuff, okay? So the concept of chains, the easiest way to look at it is it's from the distal segments perspective, hands or feet, and we look at it in terms of two questions. Is it closed to move in straight lines, or is it closed to move in angular lines? Is it open to move in straight lines, or is it open to move in angular lines? Angular lines, that's kind of an oxymoron, right? Angular parabolas, angular arcs. Angular arcs would be a better word. So I have some examples, and listen, guys, I'm not going to get into it. I want to introduce you to these concepts so that you can go off and apply them down the road and give them some thought and utilize them for your what you're going to do for a living. But again, the best way to look at this is if you are working with someone to try to teach them a new movement pattern that they've never done before, you're probably not going to have open chains, open to linear, open to angular, because it's hard to replicate those patterns. Think of it like this. When you're doing walking lunges or standing lunges where you lunge forward and then you come back and then you lunge forward and then you come back. I'm just giving it as an example. When you lift that leg up to take that step forward, that leg, let's say it's your left leg, is open. It's open to straight line simultaneous, and it's open to angular. You can move your knees, you could move your ankles. So think about this. If you did a standing lunge where you lunged forward, you came back, and every time you took a step, your foot left like a chalk print so that you could see where you stepped. If you did that 10 times, would your foot land in the exact same place all 10 times? Of course not. One time your foot may be a little bit more left, and the other time it may be a little bit more right. The other time it may be a little bit further. The other time it may be a little shorter. Why? Because it's hard to replicate the movement when you have open movement strategies. Versus when you're closed, like if you close like a squat, your feet are going to stay in the same position each time. Or a closed squat where you don't step and lunge, you just kind of fix your feet and then lunge, you're going to have more consistency. And my job is not to tell you which one's better or which one's worse. My job is to teach you that things that are open are harder to replicate movements. That's it. Harder to replicate the movement strategy. And that's typically why you progress exercises where you start off with closed close, where you can, or close when you can. Like even if you're like, well, close, what if they can't do push-ups in their body weight? Well, you modify, like you do wall push-ups, right? I mean, you could do a wall push-up where they're almost not even doing hardly any weight, but the pattern is easily replicated. If you're doing wall push-ups, you can replicate that movement pattern. You can make sure that movement is passing on those roads. The best way I heard motor programming explained, because we use catch-all terms like muscle memory, but your muscles don't have memory. Your muscles respond to nerve signals that are sent to your brain, right? So we have motor programming, and the best way I was taught about motor programming patterns is if you had an open field and you were trying to walk a couple miles to, let's say you had a club, you were growing up as a kid, you had a clubhouse at the end of a field, okay? And grass, and you take a route, there's trees or trees, let's just say grass, Brian. And you walk 2 miles to that path. The next time you walk, that pattern might be a little different. You might have, and then the next time it might be a little different. But the point is that the more you do it, a path will start to be laid out, the Oregon Trail. You start going to see a pattern of grass that's kind of pushed down. And then the more you do it, the more you're going to just start to follow that path. And your path to your clubhouse is going to get more consistent and more consistent and more consistent until literally you're walking the same path every time to that clubhouse. That's how muscles work. The first time you do a jab, it's going to be here and then there and then here and then there. But the more you do it, your body sees that path being laid down. It sees that path, and it's easier to replicate that path to where you want to get. Now, if you stop going to the clubhouse, the grass is going to eventually grow back, and that path is going to get covered up, and you're going to have to start forming a new path. Same thing with muscles. When you stop doing a movement pattern over time, you're going to start to lose that pathway. Okay? So right now, outside of just understanding that chains can be looked at in 2 different ways. Straight line motion of the distal segment, whether it's free to move forward and back, free to move up and down, or it is not free to go forward and back, not free to go up and down. And then the angular part, is that distal segment free to arc, or is it not free to arc? So again, a pull-up is closed to straight line, but it's also free to arc. You can't do this. It's closed to both linear of the distal segment and angular of the distal segment. Okay. I have some examples in your book. I'm looking at it right here. Dumbbell bench press. Open, open to linear and open to angular. I'm left-handed, so I remember when I first started lifting in high school, I was like a fiddler crab because I'm left-handed, so my left arm was a lot more dominant than my right. And so when we would do bench press, I would, especially the dumbbell, it'd be like, "Whoa," and then my right would be like, slow down, dude, because it was open. I could do stuff with my left that I didn't have to do with my right. On a push up, they kind of have to work together, right? They kind of have to work in sync. So open to linear, open to angular, and I have an example. An example of open closed, open to linear, closed to angular. Now again, that's a continuum. You could have some more closed, some less closed. That's really grad school, kind of really getting into it. I just want you to know the main ones. A machine chest press would be open to linear, closed to angular. Again, from the distal segment's perspective, it's not that you're closed to angular elbow and shoulder motion. It's just that when you're doing the machine chest press, your distal segment can't arc. Your distal segment has to go forward and back. So chest press, closed to open to linear, closed to angular. So if you think about it, if we have two different road types, linear, angular, and two different chains closed open, we should have 4 examples of all the different kind of chain options. Open, open, closed, closed, open, closed, closed, open. Again, the first one is the linear, second one the angular. So in your packet, I give you an example of all. There's an open, open, there's an open, closed, there's a closed, closed, like the push-up, and then one of the, I say the hardest one, but maybe the more difficult one is the closed to linear but open to angular. But I don't think it's that difficult. We just kind of took a lot of time and patience explaining what these concepts are. I'm going to give you a couple examples. Okay. So this is an example of closed to linear. So if you think about it, if we want to close roads to simultaneous motion, because that's really what we're saying. If we're closing the road to linear movement of a distal segment, that means we don't want multiple joints moving at the same time. If we close the road to linear movement of our distal segment, that means we need to prevent simultaneous motion. So check out this exercise, right? The leg extensor machine, or better known as the leg extension machine. You know I don't like that term, but think about it. It only allows knee motion. It only allows one, and I told you, one is a sequence. The machine, the padding, the way you're in the machine prevents your knees and your hips from moving and only allows angular movement of your distal segment, your feet. Another example in your book, look at the preacher curl machine, all right? It's closing the shoulder road, so that way you only move the elbow, and you only have angular arc motion of your distal segment, okay? From a personal training perspective, why would closing or opening roads be of importance? Because people cheat, and they don't realize they cheat. What I mean by that is this. Has anybody ever been to a gym and seen people curling maybe too much weight and they do one of these? And from their perspective, they don't realize they're not moving their elbows. They just know that the weight goes up and down. But you are like, good Lord, man, they're cheating with their back, they're cheating with their legs, they're not even using the elbow flexors. So one of the things that machines and personal training can do is help close roads so that those joints don't help you cheat. So another way to look at it. So when you get into that preacher curl position, we are closing the shoulder roads, we're closing the hip roads, we're putting you in a position where there's no cheating. We are going to close all of those cheating roads, and you're only going to be allowed to move on this road. Okay? Guys, spotting is a way to close roads. So if you think about it, if somebody's doing a dumbbell bench press and they're open, and yeah, of course you could spot them to help them, but you could also spot them to control the road that they travel. In other words, preventing independent angulation from elbows. You spot them to guide them through their movement pattern, just like an exercise machine would guide them through a movement pattern. I mean, think about it. What's the difference between a chest press machine? Well, there's a difference, don't get me wrong. But a chest press machine is a expensive spotter. That's what it is. It's a spotter. It spots you through the range of motion, making sure that you have simultaneous motion that leads to straight line movement of your distal segment. Versus if somebody's doing a dumbbell bench press and you a spotter, you would do the same thing. It wouldn't be as absolute as a machine, but you are guiding them through to ensure consistent movement patterns. Okay? So a lot of application here, a lot of stuff you guys can take from this hopefully and apply it into your work, into your clinic, into your practice. And it doesn't matter what you do. Personal training, therapy, chiropractic, even my physical educators, understanding chains and understanding how we can influence these chains. Guys, think about, I'm going to send you off with another just very practical example. If somebody's doing a balance test, my physical educators, we do the Stork stand test, and you balance on one leg. And so we can look at the right leg. Let's say I'm balancing on my right leg. We can look at my right foot being closed. It's not going to go through the ground, and it's not going to slide from the ground if I have, typical shoes on the ground, friction stuff. But everything else is open. My left leg that's off the ground, it can move linearly or angularly, and my arms can move it, and it's swaying around, and the openness of these segments are redistributing mass around my center of redistributing mass that my leg muscles have to compensate for. So what happens if you're trying to balance and you're about to fall over? What do? You grab on to something solid and you close that road. And then all of a sudden, when you close that road, it lessens your sway. It's more accurate. It's easier to balance when you close roads. Okay? Just another example of what I'm trying to get to. When you do pull-ups, people cross their legs on the bottom. That closes a road. It closes a road so that your center of mass isn't swaying all around and your muscles have to compensate for it. You interlock your legs to close that lower extremity road, at least one of the roads, so that you can have more consistent movement patterns. Cool? All right, guys, as always, if you have any questions, hit me up. Again, it's important to just know the basics, the concepts, the definitions, and practical examples. Have a good one.